Hello, in this video I'm going to be going over the basics of a heating cooling curve, also known as a freezing and boiling point graph. Right here we got a nice little graph that's looking at energy in relationship to temperature, and remember that temperature is the measure of kinetic energy. Kinetic energy is the movement of molecules. And what we have right here is A is basically a solid that is heating up. A solid could be various numbers of different temperatures and still be a solid. So right here we have a cold solid and here is a warmer solid, but it's still a solid. And as you input energy, the temperature goes up, so we'll call this solid. And then B is when it starts to melt. So this is the melting slash freezing point. Melt slash freeze, we'll paraphrase it. And as you notice, you need to put in energy, and yet the temperature does not increase at the melting slash freezing point. And why this is because you need to add energy to break those intermolecular forces, those attractions between the various molecules. Let's say between the water molecules. Let's say this whole thing is looking at just water. You need to input energy. Once all of those intermolecular forces, those bonds are broken, then they can start moving past each other in what we call liquid. So you have solid, they're just vibrating. Liquid, they're moving past each other. So right here, we have a liquid, a colder liquid, a warmer liquid, and it increases. As you add energy, temperature increases, and we'll call this liquid. And then D hits the boiling point slash condensation point. Boil slash condense. And again, as you increase energy, you are not increasing temperature. It plateaus because you're breaking those intermolecular forces further, so that now that they're not just sliding past each other, but they're totally separated from each other, floating around in a gas. And this last part is a gas. We got a colder gas to a warmer gas. And that is the heating cooling curve. We answer these questions at the bottom. It says, what is the freezing point of the substance? So the freezing point is right here, B. Looks like 5 degrees Celsius. Then it says, what is the boiling point of the substance? Well, boiling point is D. Looks like 15 degrees Celsius. Then the third one, it says, what is the melting point of the substance? That's the same thing as freezing point. Melting point, freezing point, 5 degrees Celsius. What letter represents the range of the solid is being warmed? Alright, the range that the solid is being warmed, that's right here. Solid, cold solid, warmer solid, A. And then number 5, what letter represents the range where the liquid is being warmed? Right here, liquid is being warmed, that's C. And then a vapor being warmed, that's E. Vapor being warmed. Number 7 says, what letter represents the melting of the solid? That's B. What letter represents the vaporization of the liquid? That's D, vaporizing or condensing. And what letter shows a change in potential energy? What letters show a change in potential energy? So the letters that represent a change in potential energy would be B and D. B and D. And the reason that is because, first of all, kinetic energy is molecules moving, and it's measured by temperature. As temperature increases, that's our kinetic energy that's increasing. Potential energy, our temperature is not increasing, but our energy is, so that would be considered potential energy. The next question is which shows kinetic energy. That would be A, C, and E. A, C, and E, because the temperature is rising. And what letter represents condensation? That would be D, same as boiling. What letter represents crystallization? So that would be right here, melting slash freezing, B. And those are the basics to a heating cooling curve diagram.